Hey there, ready to dive deep into some seriously cool AI stuff? Today, it's all about PyTorch versus TensorFlow, and get this specifically for building those convolutional neural networks, or CNNs if you're in the know.
Right. Always gotta love a good AI showdown.
Exactly. You actually sent over some research on this, and it gets, well, pretty detailed. So we're here to kind of like distill it down. How do these libraries actually perform, head to head?
Yeah, that's the million-dollar question, right?
Totally. So think of this as your cheat sheet if you're trying to decide between PyTorch and TensorFlow for your next project. Okay, so before we even get into the nitty-gritty, how did they even test this?
Oh, this is where it gets interesting. They used a real-world application depth estimation.
Depth estimation, like,
Teaching a computer to see depth in images, just like we do, it's pretty
hmm
amazing when you think about it.
Yeah, it is. And to do that, they use this data set, KTTI, right, full of stereo images.
Yep. It's basically giving the computer two slightly different viewpoints, like our own eyes, to work with. Pretty clever, huh?
Uh-huh. Like how we perceive depth naturally. And they built a Siamese neural network, which I've always thought was such a cool name.
Me too. It sounds way more complicated than it is. It's really just designed for these kinds of comparison tasks, where you're looking at similarities and differences.
And they actually simplified the original design a bit, right? Something about efficiency.
They did, which I thought was a nice touch, especially for folks who are all about keeping their code lean and mean.
Love that efficient coding for the win. Okay, so you know how first impressions are everything. How did PyTorch and TensorFlow stack up in the user-friendliness department?
Oh, that's so key, especially for people who are just getting started with this stuff.
Totally. We're talking ease of use, how readable the code is, do the error messages actually make sense, that kind of thing.
Right, right. So they found that PyTorch was definitely more beginner-friendly overall. Like, for example, it's got these built-in functions for common tasks, like if you need to calculate cosine similarity.
Ah, so it's got those shortcuts built in.
Exactly. It can really save you a lot of time and headaches.
Less time searching for workarounds, more time building cool stuff. Did they say anything about the documentation for each library?
Oh, yeah, for sure. They actually gave both PyTorch and TensorFlow really high marks for their documentation, which, let's be honest, is always a relief.
Huge sigh of relief.
Yeah.
Good documentation is a lifesaver.
Tell me about it. Especially when you're knee-deep in code and hit a wall.
The worst. Okay, so PyTorch is looking pretty good for beginners so far. But what about when it came to actually integrating it into their project? Was that a smooth experience?
So they found it was really straightforward with PyTorch. Installation was simple, no need to mess around with a ton of extra dependencies, which is always a plus.
Music to a developer's ears. All right, now for the moment, I know we're both waiting for speed. How'd they compare?
Okay, so this is where PyTorch really seemed to pull ahead. It was significantly faster than TensorFlow, both during the training phase, where the network's actually learning, and then again in the evaluation phase when it's generating results.
Okay, but give me the numbers. How much faster are we talking?
All right, so during training, PyTorch was about 25.5% faster.
Okay, not bad, not bad.
But get this, during evaluation, it was a whopping 77.7% faster.
Whoa. Okay, that's a serious difference. But I'm guessing it can't all be sunshine and roses for PyTorch, right? There's got to be a trade-off somewhere.
You're right, there's always a trade-off. Speed is fantastic, don't get me wrong, especially when you're dealing with these massive data sets in AI. But, it's not the only thing that matters. Accuracy is absolutely crucial.
Please tell me TensorFlow makes a comeback here. I'm on the edge of my seat.
Okay, so even though it was slower, TensorFlow consistently achieved better accuracy when it came to actually generating those depth maps. The margin wasn't huge, but it was definitely there.
Interesting. Why do they think that is? What's going on under the hood with TensorFlow that might give it that accuracy edge?
They didn't say for sure in the research, but it could be a few things, like how TensorFlow handles data internally, or maybe its optimization processes.
Could you unpack that a little bit? What do you mean by optimization processes?
Sure. So TensorFlow uses these algorithms, think like Atom or ARM-Sprop, and they're constantly fine-tuning the learning process. It's like they help the network adjust its parameters more precisely as it learns, which could lead to those accuracy gains.
So it sounds like TensorFlow might be doing a bit more behind-the-scenes optimization, even if it means sacrificing a bit of speed in the process.
That's a really good way to put it, and it's a classic trade-off, honestly. It's one of the things that makes this whole comparison so interesting.
Totally. It's like you can't just say one is definitively better than the other. It really comes down to what you're prioritizing in your project.
Right. 100%. It's about finding the right tool for the job, and this research really highlights those strengths and weaknesses.
I like where you're going with this. It's like choosing between a sports car and a workhorse. But before we get into that analogy, let's take a quick pause. When we come back, we'll dive into how these performance differences actually play out in the real world. And trust me, there are some surprising takeaways. All right, so we're back to this PyTorch versus TensorFlow showdown. It's like we've got this classic speed versus accuracy battle happening.
Totally. But, before we get too deep into which one comes out on top, I gotta ask, like, how much of this is about the libraries themselves and how much of it is the hardware they were running on?
Well, that's a great point. Because it's kind of like comparing a race car and a truck without knowing if they're both on a racetrack or like, a rugged mountain road.
Exactly. The hardware can make a world of difference.
Totally. So back to our research, did they even mention what kind of hardware they were using for all of this?
Yeah, they did. They were using a pretty high-end setup.
High-end, like.
Think like top-of-the-line GPUs, tons of RAM, that kind of thing.
Okay, so basically not your average computer.
Not even close. Which makes you wonder, right? Like, if you put PyTorch and TensorFlow on a more average machine, would you see that same dramatic difference in speed? It really makes you think.
So true. Because then maybe TensorFlow's ability to, squeeze out that extra accuracy might actually give it a bit of an edge overall, even if it takes a bit longer.
Exactly. It all comes back to that balance, performance versus the resources you have available.
It really makes you appreciate just how complex AI development can be, right? Because it's not just about the code itself, it's about understanding like this whole ecosystem.
The libraries, the algorithms, the hardware, the whole 9 yards.
Exactly. And speaking of complexity, you mentioned earlier that TensorFlow might be a bit more challenging for beginners, right? Besides everything we've already talked about, what else kind of contributes to that?
Well, I think a big part of it is that TensorFlow gives you a ton of control. Like, you can really fine-tune every little detail of the training process.
Okay, so for experienced users, I'm guessing that's awesome.
Oh, for sure. Like, if you really want to get your hands dirty and tweak things to your liking, it's fantastic.
Yeah.
But if you're just starting out with neural network,
It could be a little intimidating.
a little bit, it's like being handed the keys to a high-performance race car when you're used to driving a sedan.
You're going to need some time to learn how to handle all that power.
Exactly. And it's not just about the code itself. It's about understanding all of the underlying concepts and knowing how to apply them effectively. And that's where having really good documentation and a supportive community can make a world of difference.
And that's true for both PyTorch and TensorFlow, right?
Yeah.
Like regardless of which one you choose, you're going to want a good support system.
Oh, absolutely. And honestly, both communities have really stepped up. You can find tons of tutorials, documentation, online forums, where you can ask questions and get help from people who have been there, done that.
It's like having a whole team of mechanics in your corner ready to help you troubleshoot any issues.
The best. So we've talked about user-friendliness, we've talked about speed, accuracy, the impact of hardware, even the learning curve. But what about the future? Any insights into where PyTorch and TensorFlow are headed?
Well, that's what I'm curious about. Because technology waits for no one, right? So what's coming down the pipeline?
Well, the one thing that's for sure is that both of these libraries are constantly evolving. The teams behind them are always pushing the boundaries, adding new features, making improvements. It's an exciting time to be involved in AI, that's for sure.
So it's like this ongoing arms race to be like the best AI development platform out there.
That's a great way to put it. And it's not just about competition between PyTorch and TensorFlow either, right? There are other machine learning libraries out there, each with their own strengths and weaknesses.
Oh, totally.
Yeah.
And that diversity is good, right? It keeps everyone on their toes.
100%. It pushes the entire field forward.
I love that.
Yeah.
It's not just about picking a side and sticking with it. It's about understanding the landscape and then choosing the right tool for that specific job.
100%. And sometimes that might even mean venturing beyond the big names like PyTorch and TensorFlow. You never know. There might be some really cool, innovative tool out there that's a perfect fit for a very specific problem.
So basically, don't be afraid to think outside the box a little bit.
Exactly.
I love that. Okay, so if you're listening to this and you're thinking about diving into AI, what's like the best piece of advice you can offer? Where do you even begin?
Honestly, just start experimenting.
Just dive in.
Exactly. Don't be afraid to get your hands dirty, try things out, see what works for you.
It's like learning to play the guitar or something, right? The more you
Yeah.
do it, the more it becomes second nature.
100%. And there are so many resources out there to like help you along the way. Tutorials, documentation. You can even take online courses. You don't have to be an expert to, get started and have some fun with it.
That's so true because it can feel
Mhm.
intimidating at first, right? Like, oh my gosh, AI, this is so complex.
Yeah.
But I feel like the AI community is actually super welcoming.
Oh, for sure. It's one of the things I love about it. There's a real spirit of collaboration.
Hmm.
A lot of knowledge sharing, people from all walks of life, different backgrounds, different skill levels, but everyone's just excited to be there and like push the boundaries of what's possible with AI.
And it really does feel like AI has this power to like change the world as we know it. So it's exciting to see so many people, jumping in, exploring the possibilities.
Totally. And that's what's so inspiring, right? Like there's always something new to learn, there's always a new challenge to tackle. It never gets boring.
It's a constant journey.
100%.
Well, on that note, as we kind of wrap up this deep dive into PyTorch and TensorFlow, is there one final thought, like one nugget of wisdom you would leave with our listeners today?
That's a good one. I think the biggest thing to remember is that we focused on PyTorch and TensorFlow here, and they're fantastic, but they're really just the tip of the iceberg. There's a whole world of AI out there. So, as you get deeper into this, don't be afraid to kind of branch out and explore other libraries, other frameworks.
So don't limit yourself.
Exactly, because sometimes, a less popular tool might actually be the perfect fit for that one very specific problem you're trying to solve. So yeah, keep learning, keep experimenting. Who knows what you might discover? The possibilities are kind of endless.
Words to live by in the world of AI. This was awesome. Thanks for joining me on this deep dive. Until next time, keep those brains curious and keep those learning gears turning.